Hello, and welcome to Sleep Archive. When we visualize the terrestrial surface of our planet, human intuition naturally seeks out the presence of biological noise and fluid movement. We are engineered to recognize the rushing presence of liquid water and the vibrant growth of green canopies. When we observe a desert, our immediate perception is one of profound absence. We see an empty, static wasteland. But this perception is entirely flawed. If we strip away the expectation of familiar biology and view the deep desert purely through the lens of fundamental physics, the environment transforms. It is not an empty void. It is a massive, highly pressurized granular ocean. It is a relentless, sprawling thermodynamic machine defined entirely by extreme radiation, slow mechanical friction, and absolute fluid starvation. This environment does not exist by accident. It is the direct mechanical consequence of colossal geological forces actively manipulating the global atmosphere. To truly understand the silent, heavy power of the granular ocean, we must completely ignore the sun-baked surface for a moment. We must pull our perspective thousands of miles away and look at the massive, invisible fluid dynamics operating in the high atmosphere. The deep desert is a completely isolated thermodynamic system, engineered by the absolute physical denial of atmospheric moisture. On a standard continental plane, the invisible heavy currents of the lower atmosphere act as colossal transport vehicles. They drag billions of tons of suspended liquid water inland from the distant oceans, continuously bathing the terrestrial bedrock in a cycling fluid dynamic. The atmosphere is saturated, heavy, and active, but the granular ocean is permanently protected from this fluid invasion by a massive, immutable architectural barrier. Miles away from the absolute dry of the desert floor, the tectonic plates of the Earth's crust have collided. Over millions of years of agonizingly slow, crushing subterranean pressure, the solid continental bedrock has buckled and heaved upward, forging a colossal, jagged wall of solid stone. This towering mountain range physically interrupts the flow of the global atmospheric ocean. It acts as an absolute, insurmountable mechanical blockade. When the heavy, moisture-rich winds from the distant sea crash into the base of this massive geological armor, they cannot physically go through it. The solid, unyielding stone redirects the immense kinetic energy of the atmospheric current straight up into the sky. Millions of tons of invisible, pressurized water vapor are mechanically shoved up the sheer vertical face of the bedrock, steadily ascending into the extreme freezing vacuum of the high-altitude atmosphere. As this heavy gas rises, its thermodynamic state collapses. The localized thermal energy that kept the water suspended as an invisible, highly energetic vapor is bled away by the freezing ambient temperatures. The precise millisecond the temperature drops below the mechanical dew point, the physics of the gas shatter. The energized water molecules mechanically lock back together, steadily condensing from an invisible vapor into billions of microscopic, heavy droplets of liquid water and solid, geometric ice crystals. The immediate mechanical consequence of this phase change is localized, heavy precipitation. The massive payload of the oceanic wind is entirely unloaded on the windward side of the tectonic wall. The rain and snow relentlessly pound the rock, carving deep fluid channels and feeding the terrestrial aquifers below. By the time the atmospheric current finally crests the absolute peak of the mountain range, It has been chemically stripped of almost every single molecule of its heavy fluid payload. It is no longer a saturated, life-bringing ocean of vapor. It has been converted into an incredibly dry, highly pressurized, entirely invisible gas. As this completely starved air mass cascades down the leeward side of the mountains and pours into the massive, empty basin of the desert floor, the fluid dynamics invert. As the dry air drops in altitude, it is mechanically compressed by the crushing weight of the atmosphere above it. This sheer physical compression generates intense, localized thermal friction. The descending air mass rapidly superheats. When this superheated, completely desiccated atmospheric current finally strikes the flat, exposed bedrock of the basin, it does not bring life. It acts exactly like a colossal, invisible, highly efficient thermodynamic sponge. Because the localized atmosphere has a relative humidity of near absolute zero, it relentlessly seeks equilibrium. It silently rips any remaining microscopic traces of liquid moisture directly out of the deep soil, steadily baking the solid stone and permanently, mechanically locking the entire geographic region into a state of absolute, inescapable fluid starvation. The atmospheric blockade is seamlessly complete. As the completely desiccated atmospheric current crests the absolute peak of the high tectonic wall, the sheer mechanical dominance of gravity reasserts itself. The invisible fluid has been chemically stripped of its liquid payload, but it retains its immense physical mass. It does not simply drift over the mountain range, it cascades down the leeward slope. This is not a chaotic wind. It is a massive, descending avalanche of heavy, invisible gas, steadily plunging toward the deep terrestrial basin miles below. As this colossal volume of dry air drops in altitude, it enters a region of continuous, increasing atmospheric pressure. The fundamental physics of the gas are altered. The crushing weight of the Earth's upper atmosphere mechanically pushes down on the descending current, compressing its physical volume. The trillions of invisible gas molecules are squeezed together, their structural geometry constricted into a vastly tighter physical space. This sheer mechanical compression generates an intense, localized thermodynamic reaction. Without absorbing a single fraction of radiant kinetic energy from the sun, the internal temperature of the descending air mass steadily spikes. The microscopic friction of the gas molecules colliding under extreme pressure generates massive amounts of thermal heat. By the time this descending current strikes the flat, exposed bedrock of the deep desert floor, it has been mechanically transformed into a superheated, completely sterile, highly pressurized fluid. When this superheated atmospheric ocean washes over the solid terrestrial architecture, the chemical physics of the environment crash. The relative humidity of this compressed gas is effectively absolute zero. It is entirely devoid of heavy liquid water, creating a massive thermodynamic imbalance. The fundamental laws of fluid dynamics dictate that this extreme imbalance must be relentlessly corrected. The superheated air mass acts as a colossal, invisible sponge, blanketing millions of square miles of exposed stone. To the naked eye, the solid bedrock of the desert floor appears completely dry, an indestructible, static geometry of silicates and heavy iron. But on a microscopic level, the porous, crystalline matrix of the stone harbors infinitesimal, heavily guarded reserves of chemical moisture. Deep within the microscopic fault lines and the microscopic jagged caverns of the rock, stray molecules of liquid water cling to the mineral lattice, locked in place by weak, localized electromagnetic bonds. The superheated atmospheric current steadily invades these microscopic terrestrial vaults. The extreme thermal kinetic energy of the dry wind physically collides with the trapped water molecules. The heavy thermal radiation silently severs the fragile electromagnetic bonds holding the liquid to the solid stone. The exact millisecond the bond is sheared, the water molecule silently transitions from a heavy, localized liquid state back into a highly energetic, invisible gas. This phase change instantly ejects the moisture from the porous rock. The invisible gas is swallowed by the massive, starving atmospheric ocean above it. This relentless microscopic extraction operates continuously across the entire continent. The localized capillary action of the deep bedrock is mechanically inverted. Instead of dragging liquid water up from the deep subterranean aquifers to nourish the surface, the extreme thermodynamic demand of the dry air silently rips the chemical solvent straight out of the solid rock, hauling it into the sky and permanently deleting it from the terrestrial floor. The physical consequence of this relentless superheated evacuation is absolute structural desiccation. The deep bedrock is entirely chemically sterilized. Every single cubic millimeter of the solid terrestrial architecture is permanently bled dry of the one fluid necessary to sustain standard biological machines. The solid rock is perfectly locked into a permanent state of extreme thermodynamic starvation. It is entirely hollowed out of its chemical moisture, transformed into a massive, incredibly brittle, highly stressed physical husk. The atmospheric blockade and the extreme localized evaporation have perfectly prepared the solid, unyielding continent for the slow-motion mechanical fracturing that is about to begin. When we observe the sprawling, solid terrestrial architecture of the deep desert floor, the towering geological formations appear to be in a state of absolute, unbreakable permanence. The massive, jagged spires of exposed bedrock and the heavily armored boulders resting in the dust seem completely immune to the passage of time. Because the heavy fluid dynamics of the oceanic winds have been permanently blockaded, there is no rushing liquid water to chemically dissolve the stone, and no heavy glacial ice to physically carve the valleys. To human intuition, the absence of fluid implies the absence of erosion. But this environment is not static. It is actively, relentlessly tearing itself apart. The agent of this destruction is not a liquid, but the sheer silent mechanics of extreme thermodynamic oscillation. To understand how a solid mountain is systematically reduced to a microscopic granular ocean, we must first look at the invisible, internal architecture of the rock itself. These massive geological formations are constructed primarily of heavy silicates and dense iron oxides. On a microscopic level, they are not a continuous, single mass of matter. They are highly organized, rigid, three-dimensional geometric grids. Trillions of individual silicon and oxygen atoms are mechanically locked together by incredibly strong, localized electromagnetic bonds. This tightly packed atomic lattice is engineered to withstand immense downward physical pressure, but it possesses a catastrophic structural vulnerability. It is utterly inflexible. This extreme structural rigidity becomes a fatal mechanical flaw the exact millisecond the localized thermodynamic environment begins to shift. As the Earth physically rotates, the unshielded desert floor is rotated directly into the path of the sun. Because the superheated atmospheric ocean above the bedrock has been entirely sterilized of all heavy water vapor, there is absolutely no thermal insulation to protect the terrestrial floor. The raw, unfiltered electromagnetic radiation of the star steadily strikes the exposed geometric lattice of the stone. When this radiant kinetic energy collides with the dense outer armor of the bedrock, it is instantly absorbed. The localized temperature of the solid stone spikes. On a microscopic level, this sudden injection of raw thermal energy mechanically excites the individual atoms within the rigid silicate grid. They begin to vibrate, steadily increasing in frequency. As these heavy atoms oscillate, they push against their neighboring atoms, actively straining the rigid electromagnetic bonds that hold the solid architecture together. This localized vibration forces the solid physical mass of the rock to mechanically expand. The outer crust of the boulder physically swells, slowly pushing outward into the heavy, stagnant air. But rock is an exceptionally poor conductor of thermal energy. While the exposed outer armor of the formation is baking and physically expanding, the deep, dark, insulated core of the stone remains entirely cool and structurally contracted. This creates an immense mechanical imbalance within the exact same piece of solid matter. The expanding outer shell exerts crushing, lateral physical shear against the cold, unyielding core. The indestructible geometry of the stone is actively fighting against its own internal architecture. For 12 continuous hours, this extreme pressurized thermodynamic torque is relentlessly applied. The solid rock operates under millions of tons of localized microscopic stress, stretched to the absolute limit of its physical endurance. And then, the Earth's rotation silently severs the solar connection. The moment the sun dips below the jagged tectonic horizon, the localized thermodynamics of the desert crash. Without the heavy, insulating blanket of atmospheric moisture to trap the ambient heat, the thermal energy stored within the expanded rock instantly bleeds out into the absolute freezing vacuum of space. The temperature of the solid stone plummets at a terrifying mechanical rate. As the radiant heat escapes, the heavily excited silicon and oxygen atoms instantly lose their kinetic energy. Their microscopic vibrations halt. The massively expanded outer armor of the rock suddenly and aggressively contracts, desperately trying to shrink back to its original geometric baseline. But the slow, insulated core of the rock has barely begun to warm up. Now, the thermodynamic torque is completely inverted. The rapidly shrinking outer shell steadily pulls against the stagnant, solid interior. The rigid, inflexible atomic lattice of the silicates cannot physically withstand this relentless, bipolar mechanical torture. The unyielding electromagnetic bonds simply snap. Deep within the solid physical mass of the stone, microscopic fault lines silently tear open. These microscopic fractures slowly, relentlessly connect over thousands of localized thermal cycles, systematically compromising the structural integrity of the heavily armored exterior. In the absolute, freezing pitch black of the desert night, the mechanical fatigue finally reaches its mathematical breaking point. Without a single drop of water or a single gust of wind, the silent, stagnant air is shattered by a massive acoustic shockwave. It is the deafening, physical crack of solid rock tearing itself apart. A heavy slab of the outer geological armor shears off the main formation and crashes to the dark floor. This relentless, purely thermodynamic exfoliation operates continuously for millions of years, systematically shattering the indestructible mountains down into heavy boulders, cracking the boulders into jagged gravel, and relentlessly grinding the gravel down until the solid bedrock is entirely converted into billions of tons of microscopic, perfectly spherical silica. The solid architecture of the Earth has been mechanically dismantled to forge the granular ocean. The thermodynamic exfoliation that tears the mountains apart does not cease when the massive boulders are reduced to jagged gravel. The relentless mechanical degradation continues in the dark, operating continuously until the complex geometry of the stone is completely pulverized. The heavy iron and brittle terrestrial minerals are systematically sheared away, chemically oxidized, and lifted into the upper atmosphere as fine, suspended dust. What remains on the deep desert floor is the absolute, indestructible core of the geological architecture, pure crystalline quartz. Over thousands of years of continuous, localized mechanical friction, the sharp edges of these microscopic silicon dioxide crystals are ground down. They are systematically polished by the heavy, dry wind until they form billions of geometrically perfect, microscopic spheres. This is the silica grain. It is the fundamental, atomic unit of the granular ocean. In a standard terrestrial environment, the dark soil is a highly organized, heavily bound architectural matrix. It is physically glued together by heavy moisture, entangled in the massive subterranean grid of fungal hyphae, and chemically compressed into a cohesive, solid mass. But the deep desert is a zone of absolute fluid starvation. Because there is entirely no liquid water to forge electromagnetic bridges between the silica spheres, and absolutely no biological mass to chemically bind them together, the physics of the ground radically alter. Every single microscopic sphere of quartz exists in a state of absolute, unbreakable physical isolation. There is zero mechanical cohesion. They rest against one another in massive, heavy piles, held in place strictly by the crushing downward force of terrestrial gravity and the weak, microscopic friction of their smooth, dry surfaces. This complete mechanical decoupling perfectly primes the massive terrestrial basin for a profound physical transformation. The catalyst is not a sudden thermal spike, but the introduction of sheer kinetic energy. When a heavy, highly pressurized atmospheric current, the dry, superheated wind sweeps across the exposed basin, it physically collides with the topmost layer of the isolated silica. The invisible gas molecules strike the exposed surface area of the microscopic spheres, steadily exerting immense lateral pressure against the stationary mass. When the aerodynamic lift and the raw kinetic force of the heavy air finally overpower the localized gravitational anchor of a single silica grain, the physical geometry of the floor shifts. The microscopic sphere is lifted from the static mass and mechanically launched into the high-velocity current, but it cannot remain suspended in the thin air. Gravity relentlessly pulls the heavy crystal back down. As it crashes back into the completely decoupled floor, the massive kinetic energy of its impact is transferred. The descending grain strikes two stationary spheres, mechanically launching them into the air. Those two crash down and eject four. This is the relentless mechanical chain reaction known as saltation. Within seconds, billions of microscopic geometric crystals are lifting, colliding, and steadily ricocheting across the bare bedrock. This massive, synchronized mechanical movement completely alters the physical state of the matter. The solid terrestrial floor effectively ceases to exist as a stationary, unyielding object. Because the billions of microscopic spheres are continuously moving, bouncing, and relentlessly rolling over one another without a single drop of localized moisture to bind them, they entirely lose their solid mechanical properties. The sprawling basins decouple and begin to behave exactly like a highly pressurized, heavy, dry liquid. This granular fluid mathematically mimics the exact hydrodynamic laws of a massive terrestrial ocean. It forms colossal shifting waves. It seamlessly flows around solid, unyielding geological obstacles, and it cascades down steep inclines exactly like a heavy, silent waterfall in the absolute dark. But unlike the liquid water of a standard ocean, this granular fluid is incredibly destructive. Every single microscopic drop of this dry sea is a dense crystal of solid quartz, driven by the sheer force of the atmospheric current. As millions of tons of this heavy, flowing granular fluid wash against the remaining tectonic spires and the solid, exposed bedrock, it operates as a colossal, continental-scale industrial sandblaster. It systematically scours the indestructible geological architecture, mechanically tearing away microscopic layers of solid stone. The deep desert is not a static wasteland. It is a massive, heavily pressurized, highly abrasive liquid engine, relentlessly flowing across the continent to erase the absolute final traces of the Earth's solid architecture. Although the trillions of microscopic silica spheres behave exactly like a heavy liquid when subjected to the sheer kinetic force of the atmospheric current, they do not flow randomly. The deep desert is not a chaotic environment. It is a realm governed by strict, unyielding mathematical laws. As the heavy granular fluid sweeps across the exposed bedrock, it actively constructs its own immense, highly organized physical geography. The sprawling, shifting mountains of the deep desert are not static piles of dirt. They are massive, perfectly engineered, geometric waves of solid stone locked in a continuous state of slow, mechanical motion. The genesis of a dune begins with an infinitesimal disruption in the fluid dynamics of the wind. As the heavy, pressurized air mass carries its payload of suspended silica across the completely flat, frictionless bedrock, it eventually encounters a minor physical obstacle. It could be a solitary, heavily eroded boulder, a subtle shift in the tectonic elevation, or even the bleached, calcified exoskeleton of a fallen biological machine. This incredibly minor obstruction forces the lower boundary of the atmospheric current to physically rise and pass over it. This microscopic elevation creates a localized, aerodynamic shadow immediately behind the obstacle. In this tiny pocket of space, the immense kinetic energy of the wind momentarily drops. The fundamental physics of the suspended granular fluid instantly react. Because the atmospheric current has lost a fraction of its forward momentum, it can no longer physically support the heavy, gravitational mass of the microscopic quartz. The silica spheres silently drop out of the invisible air, steadily falling into the aerodynamic shadow and coming to rest on the bedrock. Once this initial accumulation begins, the mechanics of the environment become self-sustaining. The growing pile of heavy silica acts as a brand new physical obstruction, catching even more wind, forcing more kinetic energy to bleed away, and causing more heavy grains to drop. The granular fluid steadily stacks upon itself, slowly building a massive, highly organized geometric structure. The windward side of this growing formation is steadily pounded by the atmospheric current, compressing the silica into a long, incredibly smooth, gradual incline. The heavy wind physically drags the microscopic spheres up this ramp, pushing them higher and higher until they finally reach the absolute geometric crest of the structure. But the moment the silica spheres are pushed over the peak, the localized physics completely change. They enter the massive, stagnant air pocket on the leeward side of the dune, completely shielded from the kinetic energy of the wind. Here, on the sheltered back of the wave, gravity exerts absolute mechanical dominance. The heavy microscopic spheres silently roll down the steep back of the dune, steadily accumulating in a sheer, unbroken wall of dry fluid. But this wall cannot stack infinitely. The physical architecture of the dune is permanently constrained by a fundamental, unbreakable law of granular mechanics, the angle of repose. Because the microscopic spheres are perfectly smooth and entirely decoupled from one another by the absolute lack of moisture, their ability to stack vertically is dictated entirely by microscopic friction. As the heavy grains steadily pile up on the leeward slope, the sheer downward force of terrestrial gravity actively competes against the weak, lateral friction holding the spheres together. Through pure mathematical inevitability, this structural tension reaches a permanent equilibrium at exactly 34 degrees. This 34-degree incline is the absolute mechanical limit of the dry ocean. It is the perfect, unyielding angle of repose. The entire leeward face of the massive dune locks into this exact geometric slope. When the relentless atmospheric current pushes just a single, heavy microscopic grain over the crest, increasing the slope to a fraction of a degree past 34, the structural integrity of the entire face mathematically fails. The localized friction is finally overpowered by the crushing weight of gravity. A heavy, silent sheet of the granular fluid steadily shears away from the face, cascading down the slope in a slow-motion, liquid avalanche. This silent cascade continues until the exact 34-degree mechanical equilibrium is perfectly restored. Because the atmospheric current continuously drags heavy material up the long, shallow front and drops it down the steep 34-degree back, the entire massive geological structure is actively traveling. It is a colossal, heavy wave of microscopic stone, silently and mechanically marching across the deep continental bedrock, swallowing everything in its path and leaving absolutely nothing behind. In the deep desert, the complete absence of biological life and rushing liquid water creates an environment of profound atmospheric silence. The air is heavy, still, and completely devoid of the chaotic acoustic noise that defines standard terrestrial ecosystems. However, the sprawling granular ocean is not entirely mute. When the architectural geometry of the massive dunes reaches its physical limit, the strict 34-degree angle of repose, the resulting structural cascade generates a deep terrestrial vibration. It is a slow, heavy acoustic phenomenon born entirely of microscopic mechanical friction. As the crest of the massive dune mathematically fails and a thick sheet of silica begins its steady descent down the steep leeward slope, it does not simply fall as a disorganized, chaotic cloud of dust. Because the quartz grains have been polished into perfectly smooth, identical microscopic spheres, and because they are completely devoid of chemical moisture, They mechanically lock into a highly synchronized physical state. They form a distinct, moving sheet known as a shear layer. Millions of microscopic stone spheres steadily roll over the stationary, underlying structure of the dune in perfect mechanical unison. As this heavy, liquid sheet of solid stone slides downward, every individual spherical grain physically rubs against the surface of its immediate neighbors. In absolute isolation, the microscopic friction of two smooth silica spheres sliding past one another is acoustically imperceptible. It is a tiny, localized physical scrape. But when billions of these identical mechanical interactions occur in the exact same millisecond, moving at the exact same steady velocity down the face of the wave, the microscopic vibrations perfectly align. They mechanically compound upon one another, steadily building a massive, coherent wave of kinetic energy. This synchronized, continuous vibration is then actively amplified by the internal architecture of the dune itself. The deep, dry layers of uncompacted silica resting beneath the surface avalanche act exactly like a colossal porous resonance chamber. The kinetic energy generated by the surface friction penetrates downward into the heavy, stationary mass of the dune. The microscopic acoustic waves bounce back and forth between the tiny pockets of dry air and the solid quartz spheres. The physical geometry of the mountain mechanically filters out all the high-frequency static, steadily isolating and amplifying only the longest, deepest acoustic waves. The resulting physical emission is not a crash, a roar, or a high-pitched scrape. It is a massive, sustained, heavy mechanical hum. It operates at a frequency so deep and powerful that it perfectly mimics the steady, relentless drone of a colossal subterranean engine or the slow draw of a heavy cello bow in the dark. This low-frequency terrestrial vibration is dense enough to physically shake the deep bedrock and travel for miles through the stagnant, pressurized atmospheric ocean. It is the signature acoustic emission of the deep desert, a completely silent environment that only speaks when the heavy granular fluid steadily collapses under its own mathematical weight. As the Earth steadily continues its massive, silent rotation through the vacuum of space, the deep desert floor is inevitably turned back toward the local star. In a standard, fluid-rich ecosystem, the arrival of the sun is a gentle, heavily filtered transition. The thick, saturated atmosphere, packed with heavy water vapor and dense biological exhaust, acts as a colossal thermodynamic shield. It mechanically absorbs, scatters, and diffuses the incoming solar radiation, allowing only a fraction of the raw kinetic energy to actually reach the terrestrial floor. But the granular ocean possesses no atmospheric armor. The sky above the dunes is a completely sterile, perfectly transparent void. Because the localized atmospheric blockade has permanently starved this region of all heavy moisture, there are no suspended liquid droplets to intercept the incoming thermal payload. When the sun breaches the jagged tectonic horizon, it does not bring warmth. It initiates a relentless, unbroken wave of heavy electromagnetic radiation. This radiant energy travels across the frozen vacuum of the solar system and plunges straight through the dry, invisible air of the desert without encountering a single microscopic physical obstacle. There is zero mechanical resistance. The full, unfiltered weight of the star's thermodynamic output strikes the exposed bedrock and the sprawling granular ocean entirely intact. The exact moment this continuous wave of radiation makes physical contact with the trillions of microscopic silica spheres, a massive transfer of kinetic energy begins. The solid, crystalline lattice of the quartz is forced to absorb the heavy thermal payload. In terms of fundamental physics, silica has a remarkably low specific heat capacity. This means the microscopic spheres are mathematically incapable of storing large amounts of thermal energy without undergoing a massive, corresponding increase in their internal temperature. They do not slowly warm, they steadily, relentlessly bake. As the sun climbs higher, achieving a state of absolute vertical dominance, the intensity of the bombardment reaches its mathematical peak. The top layer of the granular ocean becomes a thermal anvil. However, this extreme heat does not penetrate deeply into the architecture of the dune. Because the billions of quartz spheres are physically decoupled, the microscopic pockets of perfectly dry, stagnant air trapped between them act as a highly effective mechanical insulator. The thermal energy is physically trapped exactly where it lands. The crushing heat is almost entirely concentrated within the top few millimeters of the shifting silica. Within hours, this hyper-localized surface layer reaches thermal extremes that are entirely lethal to standard biological chemistry. The temperature of the exposed sand climbs to a staggering 180 degrees Fahrenheit, 82 degrees Celsius. At this precise thermal threshold, the complex protein structures required to operate living, cellular engines simply denature and mechanically unfold. The surface of the granular ocean becomes an absolute, unyielding zone of thermodynamic denial. It is a completely sterile boundary layer, hostile to any physical form that relies on liquid water and delicate chemical bonds. This extreme surface temperature triggers a secondary mechanical phenomenon in the heavy, invisible fluid of the localized atmosphere. The superheated silica spheres steadily transfer their immense thermal load into the thin layer of completely stagnant air resting directly above them. As this microscopic boundary layer of gas absorbs the heat, it physically expands. Its density plummets, creating a stark, heavily stratified division between the superheated, thin air touching the sand and the relatively cooler, heavier, denser air pressing down from above. When incoming optical light, the visual information of the sky travels downward and hits this sharp, invisible boundary of differing gas densities, the fundamental laws of refraction take over. The light waves are mechanically bent. They curve upward, physically ricocheting off the superheated boundary layer before reaching the human eye. This is the precise mechanical physics of a mirage. It is not an illusion. It is a literal optical distortion forged by extreme thermodynamic stratification. The desert is so entirely saturated with heavy, localized heat that it structurally bends the trajectory of light itself, creating the false visual reflection of a liquid ocean where absolutely none exists. Under the crushing, silent weight of this solar bombardment, the surface of the deep desert is rendered completely uninhabitable. It is a heavy, highly pressurized oven of raw radiation and searing mechanical friction. To survive this daily, relentless influx of lethal kinetic energy, the highly specialized biological machines that inhabit this environment cannot fight back. They must entirely abandon the surface. As the continuous wave of solar radiation pushes the surface temperature of the granular ocean past the critical threshold of biological endurance, the deep desert floor appears entirely devoid of life. But the biological machines that inhabit this environment have not been eradicated. They have simply recognized the lethal thermodynamic shift. They do not possess the heavy, localized liquid reserves required to artificially cool their internal engines through continuous evaporation. To survive the 12-hour solar bombardment, they must execute a highly synchronized mechanical evasion. They completely abandon the exposed boundary layer of the surface and steadily descend into the solid architecture of the dunes. To understand the absolute necessity and the exact physics of this retreat, we must look at the specific microscopic geometry of the granular fluid. As established, the top few millimeters of the silica absorb almost the entirety of the raw thermal kinetic energy. But because the billions of perfectly spherical quartz grains are physically decoupled, the microscopic stagnant air pockets trapped between them act as a colossal, highly efficient mechanical insulator. Heat cannot easily conduct through empty space. Just a few inches beneath the searing surface, the internal temperature of the dune plummets exponentially. At a depth of merely 2 feet, the granular ocean maintains a permanent, stable, and incredibly cool thermal baseline, completely isolated from the crushing solar radiation above. The biological machines of the desert are heavily engineered to exploit this sharp thermal gradient. Consider the specialized desert reptiles and the highly modified subterranean mammals. They do not simply walk upon the sand. They are designed to mechanically swim through it. They operate as highly specialized, localized submersibles. Their outer biological armor is incredibly smooth, mathematically minimizing the microscopic friction of the abrasive quartz. Their limbs are modified into highly efficient, oscillating mechanical shovels. When the ambient temperature triggers their external thermal sensors, they begin a steady, rhythmic excavation. They seamlessly displace the heavy, granular fluid, sliding between the microscopic spheres and steadily pulling the cool, heavy mass of the dune down over their own bodies. As they descend into the deep, insulated dark, the heavy silica steadily collapses behind them, perfectly erasing their entry point and completely sealing them away from the superheated atmosphere. They are now entirely encased in a heavy, highly pressurized vault of solid stone and stagnant air. But simply escaping the direct radiation of the sun is not mathematically sufficient for survival. Even in the cool dark, the basic operation of a living biological engine generates its own internal thermal waste. If they continue to operate at standard metabolic capacity, they will steadily overheat within their perfectly sealed, insulated chambers, and they will systematically exhaust their heavily guarded reserves of chemical moisture through simple respiration. To counter this inevitable mechanical failure, these organisms initiate a profound, localized internal shutdown. Once they reach the optimal depth and the thermal sensors in their armor register the stable, cool baseline of the deep sand, their internal computer system systematically powers down the entire metabolic engine. The rhythmic, mechanical pulsing of their internal hydraulic pumps, the heart, slows to a deliberate, agonizingly slow crawl. The steady intake of atmospheric oxygen is reduced to the absolute bare minimum required to maintain fundamental cellular integrity. The entire biological apparatus enters a state of deep mechanical torpor. In this suspended state, they generate almost zero internal thermal friction. By drastically slowing their respiratory exhaust, they lose absolutely no heavy liquid to the dry, surrounding air. They become completely static entities, perfectly matching the silent, heavy, unchanging physics of the deep granular ocean around them. The crushing weight of the sand above them is perfectly distributed by the microscopic geometry of the spheres, ensuring they are held securely without being physically crushed. They lie suspended in the absolute dark, entombed beneath millions of tons of heavy silica, patiently waiting for the Earth to continue its massive rotation and permanently sever the localized connection to the star. They will not re-engage their internal engines or begin their steady ascent to the surface until the crushing weight of the Sun is entirely removed and the massive thermodynamic cycle violently shifts into its next phase. As the Earth maintains its relentless heavy rotation, the absolute vertical dominance of the local star is finally broken. The massive, jagged tectonic walls of the distant horizon slowly rise to intercept the incoming wave of solar radiation. The precise millisecond the physical mass of the planet fully eclipses the Sun, the continuous influx of extreme thermodynamic kinetic energy is permanently severed. The deep desert is plunged into absolute heavy shadow. In a standard terrestrial ecosystem, the transition from day to night is a slow, heavily buffered fading of light and heat. But in the granular ocean, the physics of twilight operate entirely differently. It is not a gradual fading, it is a profound mechanical collapse of the localized thermal environment. To understand the sheer speed and the absolute depth of this temperature plunge, we must return to the invisible architecture of the atmospheric blockade. In regions with heavy, saturated air, the millions of tons of suspended liquid water and atmospheric gases act as a colossal, insulating thermal blanket. During the day, the surface of the Earth absorbs shortwave solar radiation and converts it into long-wave infrared heat. When the surface attempts to radiate this heat back into the sky at night, the heavy moisture in the atmosphere physically intercepts it, absorbing the kinetic energy and bouncing it back down to the floor. This creates a stable, heavily regulated nocturnal baseline. But the deep desert possesses no such atmospheric armor. The sky above the dunes is a completely sterile, perfectly transparent vacuum of dry gas. The localized humidity remains at absolute zero. There are no suspended water molecules to intercept the outgoing infrared radiation. Therefore, the exact moment the sun vanishes, a completely unobstructed thermodynamic window opens directly between the superheated surface of the granular ocean and the infinite, freezing vacuum of deep space. Without the continuous pressure of incoming solar radiation to sustain their highly excited state, the microscopic silica spheres instantly begin to shed their massive thermal load. The intense kinetic energy stored within the crystalline lattice of the quartz is converted entirely into long-wave infrared radiation. Because the dry atmosphere offers absolutely zero mechanical resistance, this heavy thermal emission does not linger or diffuse. It travels straight up, radiating away from the dunes in a massive, invisible wave of escaping heat, bleeding directly out into the cosmic void. Because the microscopic spheres of the granular fluid have an exceptionally low specific heat capacity, they cannot hold on to their thermal energy. They surrender their heat with terrifying mathematical efficiency. The temperature of the exposed silica surface does not simply decrease, it plummets along a steep, relentless curve. Within a matter of hours, a surface layer that recently maintained a lethal 180 degrees Fahrenheit, 82 degrees Celsius, sheds almost the entirety of its kinetic energy, crashing down toward the freezing point of water. The deep desert transitions from a superheated, highly pressurized oven into a freezing, heavy plain of cold stone. This profound thermal collapse triggers a silent, microscopic physical shift across the entire sprawling architecture of the dunes. Throughout the 12 hours of continuous solar bombardment, the intense heat forced the rigid atomic lattice of every single quartz sphere to mechanically expand. Now, as the sheer cold of the night sets in, the absolute loss of kinetic energy forces the atoms to slow their microscopic vibrations. The trillions of individual silica grains steadily, inexorably contract, while the physical shrinkage of a single microscopic sphere is mathematically infinitesimal when multiplied across the sheer continental tonnage of the granular ocean. The mechanical result is a heavy, collective settling. The massive dunes silently tense and lock into a tighter, denser physical configuration under the crushing weight of the cold, stagnant air. The surface of the deep desert is now a freezing, highly stabilized, completely dark environment. The lethal thermodynamic radiation of the day has been entirely purged from the system. This extreme, freezing baseline is the exact mechanical trigger the deep desert has been waiting for. It is the precise physical condition required to awaken the dormant subterranean biology and initiate the intricate, heavy machinery of the nocturnal water harvest. Despite the absolute, crushing efficiency of the atmospheric blockade and the intense, localized evaporation of the daytime solar bombardment, the deep desert is never mathematically completely devoid of heavy moisture. The colossal tectonic walls that shield the interior continent are not a perfect, impermeable vacuum seal. A fractional, almost imperceptible volume of oceanic water vapor continuously bleeds over the jagged peaks. During the 12 hours of searing daytime heat, this moisture is entirely irrelevant. The extreme thermal kinetic energy of the localized atmosphere forces these sparse water molecules to remain in a highly energized, gaseous state, suspended invisibly miles above the superheated granular ocean. But as the deep desert plunges into the freezing, heavy shadow of the night, the physical capacity of the localized atmosphere fundamentally shifts. The fundamental laws of thermodynamics dictate that warm air possesses a massive mechanical capacity to hold suspended gas, while freezing air possesses almost none. As the sheer cold of the vacuum steadily bleeds the heat away from the shifting dunes, the ambient temperature of the heavy, stagnant air pressing down against the sand begins to plummet. As the localized temperature relentlessly drops, the microscopic kinetic energy of the suspended water molecules is steadily drained. They slow down. Their wide, energetic, invisible orbits through the heavy nitrogen and oxygen of the atmosphere begin to mathematically decay. They steadily sink lower and lower into the massive pressurized basin, physically descending through the cold dark until they brush against the absolute boundary layer of the terrestrial floor. Here, they encounter the microscopic, polished surface of the silica spheres. Because the solid quartz has already surrendered the entirety of its thermal load to the cosmos, its crystalline surface is exceptionally cold, often hovering just above the mathematical freezing point of water. The exact millisecond a slow, heavy, invisible molecule of water vapor physically collides with the freezing armor of the quartz, the final fraction of its thermal energy is instantly, mechanically absorbed by the solid stone. Without the necessary kinetic energy to physically bounce back up into the atmospheric ocean, the water molecule is grounded. It undergoes a sudden, completely silent thermodynamic phase change. The energized gas mechanically collapses back into a heavy, localized liquid. The localized electromagnetic forces of the silicon dioxide instantly lock onto the polarized structure of the water molecule, physically tethering it to the smooth, geometric curve of the microscopic sphere. This is the precise, mechanical initiation of the dew point engine. It is not a sudden, chaotic deluge. It is an agonizingly slow, microscopic accumulation that operates entirely in the absolute dark. As the deep night progresses, millions of individual water molecules undergo this exact same thermodynamic collapse. They steadily accumulate on the cold surface of the quartz. Because heavy liquid water possesses an exceptionally high degree of internal cohesion, these grounded molecules do not spread out randomly. The heavy hydrogen atoms of one water molecule mechanically lock into the oxygen atoms of another, forging an incredibly tight, highly organized structural lattice. Through the sheer physical force of surface tension, they pull themselves together, slowly building a microscopic, perfectly geometric hemisphere of liquid water on the smooth surface of the stone. This silent, heavy phase change operates continuously across the entire continental expanse of the shifting dunes. Every single exposed microscopic sphere in the top millimeter of the granular ocean is steadily, mechanically painted with a highly pressurized, localized bead of liquid dew. The total hydrostatic volume of this accumulated moisture is mathematically staggering, equating to millions of gallons of heavy liquid water resting upon the absolute driest terrestrial surface on Earth. Yet, it remains entirely invisible to the naked human eye, locked securely within the microscopic architecture of the cold stone. This heavy, silent accumulation perfectly alters the mechanical friction of the surface. The perfectly dry, completely decoupled granular fluid is momentarily, physically glued together by the microscopic bridges of surface tension. The shifting wave of the dune temporarily locks into a rigid, highly stable physical geometry. More importantly, this microscopic film of localized liquid serves as the absolute chemical trigger for the dormant biological machines entombed in the insulated dark. The deep desert has mechanically engineered its own silent, localized rainstorm entirely out of the freezing, stagnant air, perfectly priming the environment for the highly synchronized, heavy mechanical harvest that is about to begin. Deep beneath the thermal insulation of the granular ocean, the sudden, sharp drop in surface temperature sends a microscopic physical signal down through the shifting architecture of the dune. The biological machines that retreated from the searing daytime radiation are perfectly attuned to this exact thermal baseline. Within their heavily pressurized, sealed subterranean chambers, their internal computer systems mechanically register the thermodynamic shift. The state of deep torpor is systematically reversed. The localized hydraulic pumps of their tiny hearts steadily increase in frequency, forcefully driving heavy, oxygenated fluid back through their dormant biological engines. These are the harvester beetles, the heavily armored, mechanical scavengers of the deep desert. As their internal systems fully power up, they begin a deliberate, rhythmic excavation. Their highly modified, shovel-like limbs steadily displace the cold silica, pulling the heavy granular fluid downward as they slowly ascend through the solid dark. When they finally breach the surface boundary, they emerge into an environment that has been completely transformed. The lethal, superheated oven of the day has been replaced by a freezing, static expanse of heavy, moist stone. The beetles do not waste their stored kinetic energy wandering the frictionless floor in a random search for liquid. The deep desert offers absolutely no standing pools of water to discover. Instead, they execute a highly synchronized, geometric maneuver. They steadily march straight up the long, shallow incline of the wave, completely ignoring the microscopic friction of the silica until they reach the absolute, mathematical crest of the dune. Once positioned on this elevated tectonic ridge, they perfectly align their physical architecture with the slow, heavy currents of the cold atmospheric wind. They tilt their heavily armored abdomens up into the stagnant air, securely anchoring their specialized limbs into the granular floor. In this rigid, stationary posture, they cease all mechanical movement. They become completely static, operating exactly like localized, biological condensation towers. The secret to their survival does not rely on an internal chemical process, but strictly on the macroscopic physical geometry of their outer exoskeleton. To the naked eye, the rigid armor of their shell appears to be a solid, smooth plate of dark chitin, but on a microscopic level, it is a mathematically precise, highly engineered topography. The surface is covered in a dense, heavily organized grid of microscopic domes and deep, connecting valleys. This structural geometry manipulates the fundamental laws of fluid dynamics. The absolute peaks of the microscopic domes are chemically hydrophilic. They are structurally designed to mechanically attract and tightly bind to heavy molecules of liquid water. Conversely, the deep, smooth valleys between these domes are coated in a heavy, microscopic wax that is entirely hydrophobic. It completely repels moisture, creating an environment of absolute zero physical friction for liquid. As the heavy, freezing air pushes across the crest of the dune, the suspended oceanic vapor and the localized microscopic dew physically collide with the stationary biological armor of the beetle. The cold water molecules are instantly snagged by the hydrophilic peaks. They mechanically lock onto the domes, slowly, silently pulling themselves together through the sheer force of surface tension to form microscopic, perfectly spherical droplets. For hours, the beetle remains completely motionless in the dark as these liquid beads steadily accumulate mass. The heavy droplets slowly expand, drawing in more and more moisture from the freezing atmospheric current. Eventually, the droplet reaches a critical hydrostatic volume. The crushing downward force of terrestrial gravity finally overpowers the localized surface tension, holding the water to the microscopic peak. The heavy bead of liquid silently detaches. Because the surrounding valleys of the shell are completely frictionless and heavily waxed, the water does not spread or absorb into the armor. It remains a perfect, rolling sphere. Guided by the strict, angled posture of the insect, the heavy droplet mechanically rolls down the hydrophobic channels of the shell, accelerating with gravity until it is perfectly, seamlessly delivered directly into the mechanical mouthparts of the biological engine. The harvester beetle operates a completely silent, closed-loop fluid extraction system. It survives the absolute desiccation of the granular ocean by turning its own physical body into a perfectly engineered, localized thermodynamic trap, steadily draining the heavy liquid directly out of the invisible, freezing sky, while the mobile biological machines of the deep desert can physically evade the lethal daytime radiation by steadily descending into the cool, insulated layers of the granular ocean. The botanical organisms are permanently anchored to the bedrock. They cannot retreat. They are completely immobilized in the path of the daily solar bombardment. To survive the absolute desiccation of the localized atmosphere, these stationary biological machines do not function like standard terrestrial flora. They operate as colossal, heavily armored, highly pressurized subterranean water tanks. The survival of these towering structures, the massive desert cacti, relies entirely on a specialized macroscopic physical geometry and a profound internal mechanical shutdown. Their interaction with the shifting granular fluid begins deep beneath the surface. In a standard ecosystem, botanical roots drive straight down into the earth to tap into heavy, stagnant aquifers. But the deep desert basin contains no deep liquid reserves. Instead, the cactus deploys a massive, sprawling, perfectly horizontal radial grid of microscopic capillary tubes. This vast subterranean architecture rests just millimeters beneath the cold surface of the silica spheres. This shallow root network is engineered for absolute mechanical efficiency. When the freezing night triggers the localized dew point engine, or when a rare fractional mist settles over the dunes, this massive radial grid instantly activates. The microscopic capillary action mechanically pulls the heavy liquid water away from the cold quartz, steadily draining the localized surface before the rising sun can trigger an intense thermodynamic evaporation. Once the fluid is captured, the heavy biological pumps forcefully drive the water inward, pushing it directly into the central architectural column of the organism. This central pillar is not a delicate stem. It is a heavily fortified hydraulic vault. To accommodate the massive influx of heavy liquid, the exterior geometry of the vault is constructed with deep, vertical pleats. These pleats operate exactly like a heavy, mechanical accordion. As the internal volume of pressurized water steadily increases, the rigid structural folds physically expand outward, allowing the massive biological cylinder to swell and securely store hundreds of gallons of fluid without structurally rupturing under the immense internal hydrostatic pressure. But gathering the fluid is only half of the mechanical equation. Preventing its thermodynamic exhaust is the true engineering marvel. In standard flora, the exterior is covered in broad, flat leaves designed to maximize solar absorption. In the deep desert, this massive surface area would result in catastrophic, immediate fluid loss. Therefore, the broadleaf is completely deleted from the design. The outer armor of the hydraulic vault is heavily compressed into an incredibly thick, perfectly smooth layer of hydrophobic wax. This sealed outer hull is then mathematically fortified with dense grids of rigid, sharpened terrestrial spikes. These spines are not merely a physical defense against other biological machines attempting to breach the pressurized vault. They serve a distinct aerodynamic function. They physically interrupt the steady flow of the dry, heavy wind across the surface of the wax, breaking the atmospheric current into localized, stagnant micro-eddies. This microscopic aerodynamic shadow completely halts the convective evaporation of any microscopic moisture resting on the armor. The most profound mechanical adaptation of the hydraulic vault, however, is hidden entirely within its internal chemical engine. Standard biological photosynthesis requires the organism to open microscopic respiratory valves to inhale atmospheric carbon dioxide during the day, a process that steadily bleeds heavy water vapor into the sky. The desert flora mathematically cannot afford this thermal exhaust. To survive, they completely decouple their chemical respiration from the solar cycle. Throughout the entire 12-hour bombardment of raw, daytime thermodynamic radiation, the exterior valves of the cactus remain hermetically sealed. The organism operates as a perfectly closed, highly pressurized system. Zero heavy liquid escapes into the superheated atmospheric ocean. It is only when the localized heat permanently bleeds away into the vacuum of space and the deep desert plunges into the freezing, heavy dark that the mechanical locks are slowly disengaged. The microscopic valves open into the cold, stagnant air. The botanical machine silently inhales the heavy carbon dioxide, chemically binding the gas into a dense organic acid and storing it deep within its internal liquid vaults. When the sun inevitably rises and the lethal radiation returns, the outer valves perfectly seal themselves once more. The internal engine then utilizes the raw kinetic energy of the star to slowly process the stored carbon, executing a flawless, closed-loop chemical reaction while maintaining absolute, unyielding fluid retention. While the heavily armored scavengers and the pressurized botanical vaults operate on a strict, daily thermodynamic cycle, exploiting the freezing night to harvest microscopic moisture, there are other biological machines in the deep desert that require a vastly different mechanical strategy. These organisms, the desert amphibians, are fundamentally engineered for heavy liquid environments. Their soft, highly permeable outer architecture is entirely unsuited for the relentless, dry friction of the granular ocean. They cannot survive a single day exposed to the sheer solar radiation, and they cannot extract enough heavy liquid from the localized dew point engine to sustain their complex biological functions. Because the massive atmospheric blockade of the tectonic mountains can permanently starve the desert basin of measurable rainfall for years or even decades, these biological machines must completely remove themselves from the active ecosystem. They do not merely hide from the sun, they execute a profound, long-term suspension of their own fundamental physics. They enter a state of absolute mechanical pause known as estivation. The process begins with a steady, vertical descent. Using highly specialized, hardened, calcified spades on their hind limbs, the amphibian steadily displaces the heavy, granular fluid, sinking backward into the dark. It burrows deep beneath the shifting waves of the dunes, completely bypassing the microscopic temperature fluctuations of the shallow sand. It continues this slow, mechanical excavation until it reaches a depth of several feet, resting exactly at the hard, highly compressed boundary layer where the loose silica meets the solid, unyielding terrestrial bedrock. Here, the temperature is perfectly flat, and the absolute dark is completely undisturbed. But simply resting in the cool sand is structurally insufficient. Even in this deep, insulated vault, the heavy, dry mass of the surrounding silica would steadily, relentlessly pull the internal chemical moisture directly through the permeable armor of the amphibian, slowly desiccating its cellular engines. To survive the long dry, the organism must artificially engineer a flawless, localized pressure vessel. Once it reaches the optimal depth, the biological machine initiates a heavy chemical secretion. It steadily sheds the outermost microscopic layers of its own biological armor, mixing this discarded cellular material with a dense, highly viscous liquid polymer produced by its internal glands. This heavy fluid coats the entire geometric surface of the organism. As the localized, dry air of the deep sand makes contact with this fluid, the mechanical physics of evaporation begin. But the organism controls this rate perfectly. As the outermost layer of the moisture is steadily absorbed by the heavy sand, the underlying polymer completely crystallizes. It mathematically hardens into a rigid, impenetrable biological cocoon. This sealed shell is perfectly impermeable. It physically locks the remaining heavy liquid inside the biological machine, entirely decoupling the organism from the highly desiccated thermodynamic environment just millimeters away. With the external architectural vault perfectly secured, the organism must now address its internal metabolic exhaust. To wait in the heavy dark for years, it must prevent its own cellular engines from slowly burning through its heavily guarded internal reserves. The biological machine systematically triggers a massive chemical shutdown. The slow, rhythmic, mechanical pulsing of its hydraulic pump, the heart, is steadily dialed back, dropping from a standard operational frequency to merely a single faint physical compression every few minutes. The steady intake of atmospheric oxygen is reduced to a mathematically negligible fraction. To prevent the heavy liquid trapped within its dormant cells from slowly degrading or fatally shifting its chemical state, the organism floods its own internal fluid system with high concentrations of heavy organic acids. This precise chemical alteration operates exactly like a biological antifreeze, perfectly stabilizing the internal liquid architecture and completely halting the natural mechanical process of cellular decay. The amphibian is now locked in a state of suspended physical animation. It generates zero internal thermal friction. It emits zero chemical exhaust. It is perfectly preserved within its hardened, subterranean capsule, entombed beneath millions of tons of heavy, shifting silica. It is a dormant mechanical component of the deep desert, resting in absolute silence. It will not break this profound chemical torpor until a massive, catastrophic anomaly in the atmospheric fluid dynamics physically shakes the terrestrial bedrock and completely shatters the dry, stagnant environment above. For decades, the towering tectonic blockade maintains absolute physical dominance over the atmospheric fluid dynamics. It perfectly shields the interior continent from the heavy oceanic winds. But this mechanical isolation is not mathematically infinite. Eventually, a massive, highly pressurized atmospheric anomaly, a colossal weather system carrying an unprecedented hydrostatic payload, strikes the mountain range with enough sheer kinetic energy to overcome the geological barrier. The heavy, saturated air mass steadily crests the jagged peaks, completely overwhelming the standard thermodynamic evaporation cycle. As this colossal volume of heavy water vapor descends into the deep desert basin, the immense atmospheric pressure compresses the gas. Because the sheer mass of the fluid is so dense, the localized dew point is systematically breached across the entire atmospheric column. The energized vapor mechanically collapses. It does not form microscopic, silent dew. it condenses into trillions of massive, heavy liquid spheres. The fundamental laws of gravity take absolute control, steadily pulling millions of tons of dense, liquid water directly down toward the sprawling granular ocean. When this massive liquid payload physically strikes the deep desert floor, the structural response of the environment is entirely counterintuitive. In a standard terrestrial ecosystem, the porous, highly biological soil operates exactly like a colossal mechanical sponge, steadily absorbing the liquid and channeling it down into deep subterranean aquifers. But the granular ocean has been continuously baked by raw solar radiation and scoured by heavy wind for centuries. The microscopic spaces between the perfectly spherical silica grains are heavily compacted and completely clogged with ultrafine, oxidized terrestrial dust. Furthermore, the exposed surface of the sand is heavily coated in the microscopic, hydrophobic waxes continuously shed by the local biological machines and the fortified flora. Consequently, the top layer of the dune behaves exactly like a solid, frictionless sheet of impermeable glass. The heavy liquid water physically cannot penetrate the structural architecture of the sand. Denied deep subterranean access, the immense hydrostatic pressure of the accumulating water seeks immediate mechanical relief. Driven by the strict downward force of terrestrial gravity, the heavy fluid begins to move across the bare surface. It steadily gathers in the deep geometric valleys between the towering dunes, physically combining with the loose topmost layer of microscopic quartz to forge a dense, highly abrasive liquid slurry. This is not a standard, rushing river. It is a massive, highly localized displacement of heavy, fluid mass. The dense, pressurized liquid steadily flows across the flat bedrock, operating as a colossal hydraulic plow. It mechanically carves deep, temporary channels into the unyielding stone, carrying thousands of tons of suspended silica and heavy geological debris across the completely sterile continent. The sheer physical weight of this moving fluid generates a massive, low-frequency acoustic shockwave that steadily penetrates deep into the insulated subterranean vaults. This deep mechanical vibration, combined with the sudden, sharp drop in the localized subterranean temperature as the cold water washes over the surface, serves as the absolute physical trigger for the estivating biological machines. The heavy liquid slowly, steadily seeps down the sides of the unyielding tectonic bedrock, finally reaching the deep chambers where the amphibians lie in profound chemical torpor. The cold water mechanically dissolves the hardened outer biological seals of their cocoons. It steadily washes away the localized crystalline polymers, allowing the dormant cellular engines to absorb the heavy moisture and systematically restart their slow internal hydraulic pumps. For a brief, highly pressurized window of time, the deep desert has completely, mechanically inverted its entire thermodynamic state, temporarily transforming the dry, heavy, granular ocean into a sprawling, functional liquid engine. The temporary, localized inversion of the flash deluge mathematically cannot last. As the massive atmospheric anomaly steadily dissipates and the heavy oceanic clouds shear apart, the absolute vertical dominance of the sun is flawlessly restored. The superheated thermodynamic evaporation cycle engages once more, systematically ripping the localized moisture back out of the deep basin. The heavy liquid entirely retreats, and the sprawling granular ocean returns to its permanent state of extreme fluid starvation. But the mechanical action of the moving water has left behind a crucial chemical byproduct. The abrasive, flowing slurry has ground the solid terrestrial bedrock down even further, pushing past the geometric silica spheres to forge an ultrafine, microscopic mineral dust, heavily saturated with raw phosphorus and dense iron. As the exposed surface of the deep desert begins to bake under the continuous wave of solar radiation, the thin layer of stagnant air resting directly against the dunes physically expands. Its density plummets, creating a massive, highly organized thermal updraft. These invisible, rising columns of superheated gas act as colossal mechanical elevators. They effortlessly overpower the weak gravitational anchor of the ultrafine mineral dust, steadily lifting millions of tons of solid, microscopic stone high into the upper levels of the Earth's atmosphere. Once this massive terrestrial payload reaches the extreme altitudes of the stratosphere, it is entirely decoupled from the localized physics of the desert floor. It is mechanically captured by the heavy, invisible currents of the global atmospheric ocean. This is the intercontinental exhaust. It forms a colossal, sprawling river of suspended stone, thousands of miles long, steadily flowing through the freezing vacuum of the sky, completely crossing the vast expanse of the deep liquid ocean below. Thousands of miles away from the absolute desiccation of the dunes, this heavy atmospheric current finally collides with a vastly different thermodynamic environment, the dense, hypersaturated biological architecture of the deep tropical rainforest. Here, the atmosphere is heavily choked with suspended water vapor. As the dry, dust-laden current intersects with the wet, rising air of the tropics, the fundamental physics of the dew point engine operate on a massive, macroscopic scale. The heavy moisture condenses around the microscopic grains of pulverized desert rock, forging billions of dense, heavy raindrops. Gravity exerts its absolute mechanical pull, steadily dragging the mineral-rich liquid down into the sprawling canopy. This is the profound final calculation of the massive desert engine. The dense, wet soil of the rainforest is mathematically incapable of sustaining its own massive biological growth. Continuous, heavy rainfall systematically leaches all the fundamental nutrients deep into the bedrock, slowly starving the flora. The lush, vibrant ecosystem relies entirely on the continuous influx of this pulverized stone. The absolute dead, dry expanse of the deep desert is precisely engineered to be the colossal, mechanical fertilizer for the most complex biological machine on the planet. The granular ocean systematically destroys the solid mountains, only to silently, steadily feed the living world.